Suppose that you needed 2.50 grams of potassium hydroxide for a reaction. How many milliliters of a 0.80 molar potassium hydroxide solution would you need in order to have the needed amount of potassium hydroxide? The first thing I'm going to look for in this problem is my concentration unit, which is in molarity. So, molarity equals the number of moles divided by liters. Now, I look for numbers that I can plug directly in. I have my concentration in molarity, and that can substitute directly in. But for the number of moles in liters, well, for those I won't have to do a little bit more work. If I look, I have a mass of potassium hydroxide that I can convert into moles. So, if I take my 2.50 grams of potassium hydroxide, I can convert that into moles by using the periodic table. So we have 1 potassium, 1 oxygen, and 1 hydrogen in this formula. Each potassium weighs 39, oxygen weighs 16, and hydrogen weighs 1. So we have 39, 16, and 1. And if we add these together, we end up with a molecular weight of 56 grams per mole. So, I take my 2.50 and divide it by 56 to give me 0.0446 moles of potassium hydroxide. Now, I need to solve for liters. To do that, I'm going to bring the liters to the other side. It's very hard to solve for something in the denominator, so I want to move it out of that as a first step. And now I can get liters by itself by dividing both sides by 0.080. And divided by 0.80, I end up with 0.056 liters. Since my concentration only had 2 significant figures, I can only have 2 significant figures in my final answer. But I'm not quite done. The question asks for milliliters, not liters. So if I sneak in a very quick conversion factor, that there's 1,000 milliliters in 1 liter. Again, knowing which goes on top and bottom is being guided by canceling units. If I have liters on top, I have to have liters on bottom to cancel it. And now we'll end up with 56 milliliters as our final answer.